The idea is, even though they're talking about a semicircle, it means that it still means all the properties of the circle still apply. You see, that's what we should just remember. All the properties of the circle still apply. So here, this is a diameter, and if that's a diameter, well, any angle that is subtended by this diameter is going to be 90 degrees. And we would be wanting to look for that angle, as we should, because as long as this is 90, your best bet is to look for an angle. If that's the diameter, look for the angle that is 90. Just mark it
Yes.
to use. We then also have OM parallel to NB. So okay, that's useful. OM NB, that's useful. And then B1 is equal to X, right? So B1 is equal to X. Put here B1. Here is equal to X, fine. So because it's an angle inside the circle, we would be looking for another angle that is maybe also subtended by this arc, which is very important because now already we can see that O1 is double X. Do you see why it's important to not read a question and just leave it?
Yeah.
Yeah, because even though we're not seeing a full circle, this angle is subtended by the arc AM, but then O1 is also subtended by AM. If you wanted, you could easily have just put for yourself the other side of the circle if you want to stay reminded that you're dealing with a full circle, as the
Yes.
laws will apply. You can do that for yourself. Cool.
Yes.
Yeah. And then we should also not forget alternating angles and all that. So the one acronym that I actually should have mentioned quite often already is Dr. Cape Town. DRCPT. You see, this acronym reminds you of diameters, radiuses, cyclic quads, parallel lines, and tangents. You see? And then obviously phi is important because it reminds you of corresponding angles and interior angles and alternating angles. So all this being said, right? All this being said, it says here we need to get these answers now. They firstly said here express M2, B2, all the ones that have twos, except for A. Okay, there's M2, which is this one, B2, which is this one. Well, those are alternating angles, so those are gonna be equal. And then there's O2. O2 is this one here. Give it a different color. And then we have what is this? O2 and N2. N2, O2 and N2 are equal again because of alternating angles. So this one is not a difficult exercise because we technically only have to get two sets because the other ones are equal to each other. So if we get O2, we get N2 already. If we get B2, we get M2 already. Do you get it?
Yeah.
Yeah. So we don't exactly have a difficult task here. So the other thing is they say it in terms of X. When they say that you should get a question in terms of X, what they are trying to tell you is that you need to look at X as though it's like an angle given. You see, meaning here you have X, you see? So here you can look at this as 2X as we said. You see? Now, the other thing is, you see, this is like a 90-degree angle, blah, blah, blah. So do you see we also have a cyclic quad here? Yeah, we actually also have a cyclic quad, which is what you may call the what is this? AMNB. A, M, N, and B. It's a cyclic quad. So when you have a cyclic quad, Yeah, that can be useful sometimes, but we don't have any zigzag lines in here. So we don't have angles subtended by the same chord. We just have, well, what we have is, do you also see that O2 is the angle at the center? Do you see that
Yeah.
B2 is an angle at the circumference? But do you see that they're subtended by the same arc?
Oh,
If you,
is the arc still the AM arc?
no, we're now talking about O2.
Yeah.
Yeah, look at O2. O2 is subtended by this arc, right?
Mm-hmm.
Do you also see that B2 is subtended by that same arc?
Yes.
Yeah. So do you see, what does that mean then? What does that tell us about O2 and B2?
That they're equal.
If they're subtended, but no, if O2 is subtended by this arc and B2 is subtended by this arc, remember O2 is the angle at the center, B2 is the angle
Oh,
at the circumference.
that O2 is O2 is double B2.
Yes, O2 is double B2. So if we want, we could actually just start there, because it means as long as we get any of these angles, we're actually home free. That's literally all it means here. So let's start off by writing that. You see, O2 is double whatever B2 is. Your reason there is angle at center of circle. You see?
Yes.
Yeah. So as long as you have this angle at the center of the circle, you already know that it is double this one here. So that makes life a bit easier for us, because we now see that, okay, our job is to just get one of these angles. As long as we have one of them, we have the rest. You see? So we don't want to overthink it. We don't want to overthink it. So let's maybe try and see what we can do. Let's see, what else did they tell us? They told us these are parallel, so we have fun. Oh yeah, corresponding angles. Yes. So do you see that if this is 2x, which other angle is also equal to 2x? Because which angle is corresponding to O1?
The whole of B.
Yes, the whole of B. So this makes things very interesting for us, because now we know that the whole of B is actually equal to 2x. But then one part of B is equal to x. So if one part of B is equal to x and the whole thing is equal to 2x, you see we already know what the other side is.
Yeah.
Yeah. But so now we just need to be able to craft it into a statement and reason. So the first thing is, we say that O1 is equal to the entire angle B, right?
Yes.
Yes. So we tell them that and we give them a reason. That's where we start. So let's do that. We said here O1 is equal to what?
The whole of B.
Yes. And what's our reason?
Corresponding angles.
Yes. So now that the whole of A is equal to the whole of B is equal to O1, you see now we know that O1 is equal to 2x, but we haven't told them we know that. So do you see we have to tell them we know that O1 is equal to 2x so that it can be useful to us.
Yes.
Yeah. So yeah. So with all this information, now we can tell them that B is also equal to 2x because of O1. So we have to tell them that O1 is equal to 2x because it is double the B1. So here you can say angle at center of circle. You see?
Yeah.
Yeah, it's an angle at the center of the circle. So we have now told them that this is 2x. We have now told them that this is x, and we have told them that the whole of it is 2b. So I mean, is what you call the entire thing. We told them it is equal to 2x, and one part they already told us that it is x. So here, because we already told them that these are equal and that this is equal to 2x, we can then easily say that therefore here b2 is equal to 2x minus x, which is equal to x. There's no reason for, you can't necessarily think and say what's the reason. This is more of a conclusion based on the
Yeah.
information that you see. They gave us the information that what you call, they firstly told us that this angle is x, and we have proven that this one is 2x. So if this whole thing is 2x, if you minus x, it means that this one is equal to x. You see? And now
Yes.
the floodgates are open because we now have answers for everything else. You see? If this is x, it means that this one is going to be, remember we said b2 is double, I mean 2 times b2 is equal to O2. It's something we already stated. So here we can then say O2 is equal to 2x. The reason is angle at the center. This is O2 is an angle at the center. It is double the angle at the circumference. So we can say it again using the same law. Angle at center of circle. So it's so funny that we have used the same reason literally the whole time here, but it's still
Yeah.
fine because the law does not lie. See, so now that we have told them that O2 is also equal to 2x, we can tell them that O2 is equal to N2, right? And what's the reason?
And O2 is equal to N2.
Uh-huh.
Oh,
What's the reason?
alternating angles.
Pardon?
There's not an alternating angle.
Yes, alternating angles. Yes, so now that we have gotten all this, what is the angle of M2 then?
M2.
Uh-huh.
It's equal to, it's not equal to B2.
Yes, and what's the reason?
Also alternating angles.
Yes, also alternating angles. The funny thing is with M2, it looks like we could have also said M2 is equal to B1 because they are base angles of an isosceles triangle. Because you see that OM and OB, they are both the radius of a circle.
Yes.
Yes, so it means that we have an isosceles triangle, you see, meaning that M2 would be equal to B1. You see?
Yes.
Yes, so that's important. So here, M2 is equal to B1. We can even say it's equal to X. The reason will be, now let's just use the B2 one, because it's more straightforward and more streamlined. The reason here is just alternating angles. There we go. There we go. So, yeah, that's a lot, but it's fine. Now they say express K1 in terms of X. So, yeah, when you have to express something in terms of X, here, without wasting time, right?
Yeah.
Kind of out. We have this line here. I'll just give you a hint. We have MB here. It's a straight line, you see. And there's K here, you see. And then we have N here, you see. And then we have 2B here. We have K1 here. And we have N2 over there. But then here, the key thing is that this one is, we have proven it to be 2x. This one, we've proven it to be x. Do you see that? What do you note about this angle here based on the image that I've shown you?
Oh, it's an exterior angle.
Yes, it's an exterior angle of what? Of this triangle, right?
Yes.
100% away. That is very important to note because that gives us the answer we need. See, so now that since we know that's an exterior angle, right? Let's say here, let me just make sure this is just one color. So here, this is question number 2, right? Here we can say K1 is equal to N2 plus B2. What's the reason? Exterior angle of exterior angle of a triangle, right?
Yes.
Yes. So K1 is equal to 2x plus x, which is going to be 3x. There you go. So the last two questions here, it says, if it is given that x is 30, calculate the size of the angles of triangle M, K, N. I think you'll be able to do that one. As a hint, well, this is already 3x. So that gives us that angle. And also, what we know is, let's see, angles subtended. Yeah, the other thing is, you see that this is 2x, this is 2x. And the other thing is, O3 is double M3. Because this is the angle at the circumference, this is the angle at the center, this is the angle at the circumference. You see, they are both subtended by the same arc. You see, O3
Yes.
and M3. Do you see it?
Yes.
Yeah. So make use of that information because already you know that this part here is giving you 180 degrees minus 4x. So they already gave you x is 30, so you can use that information to get M3. And then once you have M3, you also have this angle here. Getting N1, it's also then going to be easy because of the interior angles of the triangle.
Wait,
See,
when you say 180 minus 4x, does that mean like the place where k is like the letter, that would also be equal to 3x?
no, here I'm talking about O3 only. Because you see these are angles in a straight line.
Yes.
I'm talking about, yeah. Oh yeah, that also you could, oh yeah, you can, it's two ways of getting this part. Here, if you use this triangle like you're saying, yeah, it's fine. Because in this triangle, this is equal to 3x because of, you know, vertical opposite. So if you also say 180 minus x here minus x here, it's still also going to give you 4x. Me, I
All
had
right.
said 180 minus this 2x minus that 2x and used angles on a straight line, but it's still fine. The answers are still correct.
Okay.
Great.
Great.
So now this one here, this one would have been, is asking us to prove a rhombus, but the first thing would be to ask yourself, what is a rhombus? Because if you know what a rhombus is, you will know at least where to start. So what is a rhombus?
A rhombus is quadrilateral.
Pardon?
It's a parallelogram.
Yes, it is a parallelogram, but what is the key thing about a rhombus? The opposite sides are parallel, yes, but what else? What is the one thing that's key about a rhombus?
Is that the opposite angles are equal?
Yes, they are equal, yes, but those are still all properties of a parallelogram. What
Oh,
kind of a parallelogram is a rhombus?
it is not something about the bisecting lines. I forgot what it is.
Well, fine, but the key thing is, remember, a rhombus is just a slanted square.
Yes.
The key thing is that all the sides are equal. Because when you mention all those other things that you're talking about, it's still just talking about a parallelogram in general. It does not then specialize and go into a rhombus. You see, because the only thing that allows you to then specify that it's a rhombus based on all those things you're saying is if you say that all the sides are equal. You see,
Yes.
it's a slanted square. That's what should just ring in your head. A slanted square. Because remember, when you hear the word square, you remember that, oh wait, all the sides are equal. So a slanted square is a rhombus. You see. So if you're gonna prove that M O V N is a rhombus, well, the fortunate thing is here you will need what do you need now? Yeah, here the fortunate thing is it's not a difficult question, because here we already know that OB is equal to OM because they are radii. You see,
Yes.
yeah. In this question here, question number 4, right? OB is equal to OM because they are radii. You see, so that covers half the job. Now, since you have shown that those two are equal to each other with those what you call perimeters or whatever you want to call them, or rather, as long as you've shown that at least these two sides are equal, the next thing you can do for yourself is to then find one other property of a rhombus specifically, because with these two, they are not necessarily parallel, but you've shown that they are equal. The next thing is these are parallel, right? MN is parallel to NB. That's the second thing to mention, because that's another property of your rhombus. So we said here MO is parallel to NB. You see, that one is given. You see, so you have shown that two sides that are not opposite to each other are equal, and you have shown that two sides of that shape that they're talking about are equal. So that's two things. So you'll just now need like one last thing to prove that your shape is a rhombus, and you can easily use the angle O2 and the whole of n, because remember here you already have an angle, and then here you also have an angle, and then for O3, remember you already automatically have an angle there, and for O2 you have an angle there. So the last thing is you would be needing to show that this angle is equal to that one. You know, you need to show that angle MOB is equal to MNB. You see, here by this time it would have been proven, because all these angles here, they would have added up to all the angles here also. You see?
Yes.
Yeah, that's very important. So for your homework, you see, you need to write down this one. You obviously still have to do it, and this one, cleaning it up, you can use what we wrote here, because I'm gonna send you this PDF file. And then also you see these other ones that was circled for homework. These ones you also definitely can do based on what we have just looked at. These are going to be not difficult. For this one, don't get confused. This is not a cyclic quad, because not all the points are on the circle. So that's not a cyclic quad. But you can still use the fact that these are parallel. So as long as those are parallel, you have this as 180, as 130 also. And if this is 130, it means that, remember, an angle at the what you call, an angle at the center is double the one at the circumference. So this angle here, right, is gonna be equal to 260, because the angle at the center is double the one at the circumference. You see, so that kind of information is important for you to know. And then something like P, you'll also be able. So that's that for now. Stop this.